Hello. In this video we're going to talk about the continuity of functions. Now, a function is continuous if it's connected by a smooth line and curve around a certain point. Specifically, we say we're continuous at A if first of all, our function is defined at A. The limit of the function as we approach A exists, and the limit as we approach A is the same as f of A. If we're not continuous at A, or if any of those three things fail, we say f is discontinuous at A, or has a discontinuity at A. On the next slide, we're going to see an example of a function with several discontinuities. So here's the function f, and the question is, at which numbers is f discontinuous? Now, the first place I notice is right here. I have an open circle at an x value of 0, and so we are discontinuous where x is 0 because f of 0 is undefined. So that's one place where we're discontinuous. Another place I notice is right here. Now in this case, f of 3 is defined. F of 3 is equal to the number 2. But the limit as x approaches 3 of our function doesn't exist. Notice that as we approach from the right, we get one result, and as we approach from the left, we get another. So because that limit doesn't exist, we have a discontinuity where x is 3. And finally, I have a third discontinuity right here. And this one is because even though the limit of f of x as we approach the number 5 exists, it goes to a value of 6. But f of f of 5 is actually equal to 1. So the limit as we approach 5 of f of x is not equal to f of 5. So we have another point discontinuity at 5. And so that is an example of when a function is discontinuous. Everywhere else on this function appears to be continuous. Notice it's connected by a smooth curve at all other points. For the time being, we are done.